Today we will be using the distance formula. We have two objectives. One is to find a point on a segment that portions a segment into a given ratio, and then our second objective is to use the distance formula. So we're going to talk about what happens when we cut a segment, but not in half. Yesterday we talked about bisecting segments where we cut a segment in half, but what if we want to do into thirds, fourths, or fifths, and so on? And how that could change the midpoint formula. So let's look at this example. We're going to first find the length of this given segment. We can easily count 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of this segment is 9. Now for letter B, it says if you begin at the leftmost point on the segment, what point is 1/3 of the total distance? Well, because it says 1/3, let's find out what that would be. So the length is 9, divided by 3 is 3. So 1/3 of this segment is 3 units. So now we can go back and say, all right, if we begin at the leftmost endpoint, which is right here, it says what point is 1/3 of the total distance? So the 1/3 of the total distance is 3. So let's count 1, 2, 3. The question says what point? Well, that point we are at is 0. And then the last one, what point is 2/3 of the total distance from the leftmost point of the segment? Okay, so this one's talking about 2/3. Well, if 1/3 was 3, that means 2/3 is 6. So again, we're going to start at the leftmost endpoint because that's what it's telling us to do. And we're going to move 6 units. 1, 2, 3, 4, 5, 6. And we end at point 3. All right, let's move on to example number 2. We have a segment. Let's find the length of it. So let's count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 units. If you begin at the rightmost, okay, so last time we were talking about the left part, we start at the leftmost point, rightmost. What point is 1/5 of the total distance? So 1/5, we'll take the length of this, 10, divided by 5 is 2. So that is going to be like our magic number to kind of go by. And the question says, what is 1/5 of the total distance? So we got to go 2 from the rightmost endpoint down to 2 units. And we end at 0. That is the point that we end at. Then letter C, what point is 3/5 of the total distance from the rightmost endpoint? Okay, so here we are at the rightmost endpoint again. 3/5. Well, if 1/5 is 2, 3/5 will be 6. 2 times 3. So let's move 6 units. 1, 2, 3, 4, 5, 6. And we end at the point -4. Okay, so how can that be useful for dividing segments into ratios? When we were talking about the midpoints yesterday, we took our points and we divided by 2, right? We added our x1 plus x2 and divided by 2 because it was a midpoint. Up here, look at, we divided by 3 because we wanted 1/3 the distance in the thirds. So down here, we wanted 1/5, so we divided by 5. So whatever we want to cut our segment into, we would just add the coordinates and divide by whatever number it was, 5, 4, whatever it is. All right, let's look at the next page. For these questions, we're going to use algebra to solve them, and then we can look at the graph to kind of check our answer or to help us out after we do the algebra. So find the point that is halfway between the points 1, 5 and 1, 11. So remember the midpoint formula. We're going to add our x1 and x2 together. So we have 1 plus 1 over 2, 5 plus 11 over 2. So that is our point. So 1 plus 1 is 2. 2 over 2 is 1. 5 plus 11 is 16. 16 over 2 is 8. So that is our midpoint. Find the point that is halfway between the points -5, 8 and 4, -7. So again, let's add our x's. -5 plus 4 over 2 and 8 plus -7 over 2. -5 plus 4 is -1. -1 over 2 is -1/2, or you can write it as -0.5. I will leave it as a fraction. 8 plus -7 is +1, so that gives us +1 over 2. Again, you could write that as +0.5. Now for C, it says find the point 1/4 of the way from 0, 4 to 0, 2, beginning at the bottom point. So for this one, what I think we should do is say, okay, how long is that segment from 0, 4 to 0, 20? And we have a picture over here to kind of help us out. How long is this segment? You could count that and you will get a distance of 16. We do 16 over 4. That gives us 4. So 1/4 of the distance is going to be 4 units. Now, if we're beginning at the bottom point here, and we're going up 4, 1, 2, 3, 4, that is the point that we are at, and that is 0, 8. Then find the point 1/4 of the way from 0, 4 to 0, 20, beginning at the top point. So here, and we're going to go down for 1, 2, 3, 4. And that point is 0, 16. Now, to find the distance of this segment from here to here, you could have counted, or you could have also said, wait a minute, because the x coordinates are exactly the same, you could have done 20 minus 4, and that gets you 16. So anytime you have a vertical or horizontal line, you can just subtract the non-zero coordinates. In this case, it was 20 of 4, and that'll get you the length of that segment. Or you can just count it, but remember, if the segment is long, like what if this said 0, 4 and 0, 200? Okay, that might be a little bit difficult to count, so you could use subtraction instead. Now, the distance formula will let us calculate the distance of segments that are not completely vertical or horizontal. Here, like I said, we could just subtract the non-zero coordinates and boom, we're done. But what if we were asked to find the distance between these 2 points? That's where we use the distance formula to help us out. Now, the distance formula looks pretty ugly. I'm not going to try to sugarcoat it or anything, because you have 2 sets of parentheses, you're subtracting them, and you have squared, the second power here, and then you have a square root. So it's pretty ugly. to help me memorize it, what I usually do is I just always write it down when I use it. That way, by the time I'm ready for the quiz or test, I've written down the formula several times and I'm committed it to memory. So what is the length of RT with these endpoints? So just kind of like the same thing we did with the midpoint formula, I'm going to label my points. And then in the formula, I'm going to plug in what we are given. Okay, so x1 is 1, so I'm going to plug that in for x1. x2 is -2, I'm going to plug that in for -2. y1 is 3, and y2 is 6. So I'm going to make those substitutions. Okay, so we get -2 minus 1 squared plus 6 minus 3 squared. So then RT is equal to -2 minus 1 is -3. So we get -3 squared plus 6 minus 3 is 3 squared. -3 squared is 9, and positive 3 squared is 9, so RT is equal to the square root of 9 plus 9. RT equals the square root of 18. So then at that point, we can use our calculators to get a decimal approximation for this. And we get 4.24. That is our answer. So always 2 decimal places, and we round to the nearest hundredth, which is the second decimal place. All right, now example B. What is the length of GH with endpoints at 4, -2 and -4, 5? So let's label these x1, y1, x2, y2. So then let me write out the formula. x2 minus x1 squared plus y2 minus y1 squared. Now, sometimes I'll get asked, does it matter which point you make x1, y1, and x2, y2? It doesn't matter as long as you are consistent. Like I could go back and you still get the same answer. I can make this one x2, y2, and x1, y1, and I would still get the same answer. What you can't do, though, is mix and match. And what I mean by that is say, okay, this is x1, y2, x2, y1. You can't do that. You won't get the same answer. So as long as you're consistent, it won't matter. So x1, let me write back what I had. And we can plug in and get our answer. So x2 is -4. So -4 minus 4 squared, plus 5 minus -2 squared. -4 minus 4 gives us -8. Plus 5 minus -2, well, minus a negative makes it an addition problem. So that gives us +7 squared. So then we get 64 plus 49. That equals the square root of 113, and that equals 10.63. Now, I get asked a lot, can I just put this into my calculator? I would still like to see you do this work, because then I can see if you messed up somewhere and where you messed up at. It's very easy to type something wrong into your calculator, and then I won't know where that mistake was. So please just write it out for now until I get used to the mistakes that you might make. All right, let's look at the next page. So I am a hockey person, and it's my favorite sport. I played it, I watch it, and our hockey rink could be thought of as a grid, and we can calculate the distance between certain parts of the rink. So what I'm going to do is I'm going to kind of start you on this problem, and then I'm going to have you finish it, and then when we come back together, I'll look at it and we'll discuss the answer you got. So the upper face-off dot is represented by the point 31, 64. Upper face-off dot in the defending zone. So this point right here. That's 31, 64. And then the lower face-off dot in the attacking zone right here is represented by 154, 20. So go ahead and find the distance between that. Think about it. If I'm going to pass the puck from here all the way down here, how long did that pass travel? So go ahead, try it out, and then we'll talk about this the next time I see you. So thanks for watching the video. Make sure you hit the like button and subscribe.